Lesson 4. Bending stress in beams. Last lesson we twisted a shaft, now we bend a beam. 3 one-line ideas. A bending moment makes normal stress that grows toward the outer fiber. That stress rides on the section's moment of inertia the way torsion rode on the polar moment. And before you can plug in, you have to find the maximum moment along the span. Get those 3, and beam problems fall out fast. Here's the problem. A simply supported beam spanning 4 meters carries a 12 kilonewton load right at midspan. The cross-section is a rectangle, 50 wide by 150 deep, bending about its strong axis. Find the maximum moment, the section's moment of inertia, and outer fiber distance, and the peak bending stress. Notice the load is a force, but bending stress feeds on the moment. So the first move is always finding the maximum moment. Concept 1. Bending stress. Bend a beam, and every fiber along the depth carries normal stress, but not equally. It climbs straight from 0 on the neutral axis to a maximum at the outer fiber. Sigma equals mc over I, moment times the outer fiber distance, divided by the moment of inertia. One face is squeezed in compression, the other stretched in tension. The moment of inertia does for bending exactly what the polar moment did for torsion. Concept 2. The moment of inertia and the section modulus. The cross-section resists bending through its moment of inertia. A rectangle gives bh cubed over 12 about the horizontal axis. A solid round gives pi d to the 4th over 64. Notice depth dominates. The rectangle scales with the cube of its height. Bundle the moment of inertia with the outer fiber distance once into the section modulus. S equals I over C. And the peak stress collapses to just m over s. Concept 3. Maximum moment first. Bending stress is biggest where the bending moment is biggest. So before you touch the stress formula, you locate the maximum moment. For a simply supported beam, these 2 cases are worth memorizing. A central point load gives PL over 4 at midspan, and a uniform load gives WL squared over 8 at midspan. Read the case off the beam formula table, then hand that maximum moment straight to sigma equals mc over I. Setup. Build the table. Load, span, width, and depth up top, then a blank with its formula for every unknown, the maximum moment, the moment of inertia, the outer fiber distance, and the peak stress. Then commit to 1 unit system. I'll work the moment in Newton millimeters with the section in millimeters, so the stress lands directly in megapascals. The one conversion to stage now is the load in newtons and the span in millimeters before you build the moment. Solve. Part 1. Maximum moment first. For a central point load, it's the load times the span over 4, carried in Newton millimeters. Then the section properties, the moment of inertia, bh cubed over 12, and the outer fiber distance, just half the depth. 2 numbers set, and the peak stress falls straight out. Part 2. The peak stress. Maximum bending stress is the moment times the outer fiber distance over the moment of inertia. Cross-check it through the section modulus. Divide the moment of inertia by the outer fiber distance to get the section modulus. Then the stress is simply the moment over that section modulus. 2 routes, 1 answer. That agreement is your confidence the section properties are right. Final answers. Maximum moment, 12 kilonewton meters. Moment of inertia about 1 4/10 times 10 to the 7th. Peak bending stress, 64 megapascals at the outer fiber. All of it hangs off that first step of turning the central load into the maximum moment. Miss the moment, and every number after it is wrong. Traps. 3 ways bending bites. 1. The axis. For a rectangle bending about its horizontal axis, the moment of inertia is bh cubed over 12, not hb cubed over 12. Use the axis perpendicular to the load. 2. The outer fiber distance is to the farthest fiber, half the depth for a rectangle, half the diameter for a round. Never the centroid to something closer. 3. Find the maximum moment first. Bending stress rides on the biggest moment along the span, so locate it before you plug in. Quick recall. Find the maximum moment. Load times span over 4 for a central point load. Load times span squared over 8 for a uniform load. Peak bending stress is the moment times the outer fiber distance over the moment of inertia. or equivalently the moment over the section modulus. The moment of inertia is bh cubed over 12 for a rectangle, pi d to the fourth over 64 for a round. Golden rule: get the maximum moment first, then stay in one unit system. Next up, Lesson 5, Transverse Shear in Beams. Today, the moment made normal stress out at the fibers, but the same load also pushes a shear force along the beam, and that makes a shear stress. Tau equals VQ over IB, biggest right at the neutral axis, exactly where bending stress vanishes. Next lesson, we pair them. Before then, redo today's beam as a solid round, same maximum moment, and watch the stress change. Everything's at pprepengine.com. Cheat sheet, work solution, and a quiz attached here.